this episode of Nova Science Now. Ask a scientist what the universe is made of.
We don't know what it is.
It's completely invisible.
The answer will be dark matter. Mysterious and crucial.
We wouldn't be here if it weren't for the dark matter. Life wouldn't be possible.
But what is it?
Yeah, that's a big question.
Dark matter hunters are looking everywhere to find out, including deep underground. Whoa, what is this thing?
That's a bat.
That's nasty.
It is kind of
nasty. All to solve one of the universe's biggest mysteries.
Discovering dark matter is going to be one of the greatest finds of the century.
Also,
do you remember who these folks are?
For many of us, holding on to even the most precious memories is impossible.
Those are your great-grandchildren.
Really?
But new research indicates there may be hope.
That memories can be stored, apparently lost, and then regained.
And these swimming lab mice may hold the clue.
They can find a platform much faster.
Their brains have been experimentally rewired to help them recover a lost memory. How to swim to safety.
And when you realized that, what did you think?
I was overjoyed.
I think these experiments are just plain amazing. They tell us that there's so much more potential in situations where we might have given up all hope.
And in the digital age, how do we know if the pictures we see are real or fake? Here's a Harley-riding computer scientist who thinks he has the answer.
Think forensics the way you would think CSI forensics, but now it's pixels instead of hair.
He's a digital detective who spends most of his time creating fakes and forgeries.
When I am creating a forgery, it is a little bit like being an artist.
In our profile, art meets science in the interest of putting the real phonies out of business.
I'll be able to create fakes, but you won't.
All that and more on this episode of Nova Science Now. Hi, I'm deGrasse Tyson. Welcome to a new season of Nova Science Now. Now, I'm an ordinary guy, and that means, of course, I'm made up of ordinary matter, basically atoms. And when we gaze out into space, everything we see, galaxies, stars, is also ordinary, made of atoms. But a lot of scientists say there's something else in the universe that's not ordinary. Wait, who said that? And by the way, there seems to be way more of this weird stuff than ordinary guys like you. Watch it. And even though it's invisible, it's getting harder and harder to ignore. Every day, a crew squeezes into an 80-year-old elevator in Minnesota and commutes to work a half a mile down into the depths of an abandoned mine. They're not searching for gold or diamonds. Instead, they're mining for something even more coveted and harder to find. Something called dark matter.
Dark matter is one of the biggest mysteries.
Dark matter is everywhere.
We wouldn't be here if it weren't for the dark matter. Life wouldn't be possible.
Problem is we have no clue what the dark matter is.
We know it's out there, and we just have to find it.
One of the people now trying to find dark matter is physicist Hany Farid.
Discovering dark matter is going to be one of the greatest finds of the century.
So they really mine iron in this place. His search takes place a half-mile underground, where this old iron mine has been transformed into a cavernous space-age physics lab. When I visited, I didn't notice any dark matter, but I did see quite a bit of dead matter. Whoa, what is this thing?
That's a bat.
It doesn't look very alive.
Well, it probably isn't.
Whoa, there's one. Yep. Another.
They're all over the place.
That's nasty.
It is kind of
nasty. So that doesn't creep you out?
You get used to it.
Okay. Down here, surrounded by the dead bats, Tali and his colleagues monitor and care for a complex contraption, specially designed to detect particles of dark matter. So this is it, huh? Yep. This elaborate endeavor is all to solve a mystery that's been plaguing astrophysicists for more than 70 years.
Okay. Yep.
It might seem bizarre, and even a bit crazy, but there's a chance that most of the matter in the universe is not stars or planets or gas or anything familiar to us, but is in the form of some mysterious, invisible substance. We've labeled it dark matter. But why do we think it exists at all? It comes down to gravity and speed. Ever since Isaac Newton, we've known that it's gravity that holds objects in orbit, just as the sun holds Earth and the rest of the planets. The stronger the gravity pulling it inward, the faster an object can go and stay in orbit. It's kind of like spinning a heavy ball around. The harder you pull on the ball, the faster the ball will travel. If the ball gets moving too fast, even a strong guy like this has got to let go.
The faster you want something to go, like, David throwing his slingshot, the more you have to pull on it. And the thing that's pulling on something to make it orbit is gravity.
And where does gravity come from? Well, we know it can be things with mass, like stars, houses, planets, trains, clouds, jellyfish. They all have gravity. So in the universe, the more stuff, the more gravity, and the faster objects can move and remain in their orbits. Problem is, when we look out beyond our solar system, like at stars orbiting within galaxies, or galaxies moving within galaxy clusters, they're all orbiting faster than we'd expect.
The speed at which the stars are going around at is too fast. You would expect that it should just escape, but those stars don't escape. They're still going around.
There's got to be a lot of gravity holding them all together, but apparently there's not enough matter to account for it.
And there's not enough stuff. There's just not enough stuff to keep them all going around each other.
Regardless of how we probe the cosmos for this missing matter, using visible light, radio waves, X-rays, we still come up short. Either we've got the laws of gravity completely wrong, or there's got to be more stuff. Actually, we need about 5 times more stuff. It's stuff we can't see. But what exactly is it?
What is dark matter?
What is the dark matter?
Yeah, that's a big question.
We don't know what it is.
It's completely invisible.
It's dark. It doesn't glow.
So whatever the dark matter is,
we can't point a telescope up and actually see it.
It sure ain't made of atoms.
Everything around us that we can see and touch, ordinary matter, is made of atoms. But one thing we know is, dark matter is not ordinary.
We know it's not ordinary matter because ordinary matter has this whole other variety of interactions. It has electric fields and magnetic fields, it emits light.
One idea is, since it's not made of ordinary atoms, dark matter might be made of some exotic particle. Right now, physicists around the world are racing to build a detector sensitive enough to capture one, so they can figure out exactly what it is.
It's working fine.
But how do you catch a particle that's so shy?
The fundamental problem is that this dark matter does not interact with matter very much. And so in order to detect it, we have to build these really specialized, very sensitive detectors.
At this underground lab, Tali Figueroa is monitoring one kind of dark matter detector, a superconducting crystal made from the element germanium. So one of your detectors, huh?
Yes, this is a prototype of one of the 30 detectors. And when you look at the surface of our detector, you'll see a metal grid.
The grid picks up tiny temperature changes produced when a particle hits the crystal and sets all its atoms vibrating. But to detect those vibrations, the atoms in the crystal have to start out as still as possible, something atoms don't normally like to do.
The problem is that naturally, at room temperature, the atoms are vibrating themselves.
So how does the team manage to slow down the detector's atoms? They put it in a freezer, a very powerful freezer.
So the whole point of this is to simply keep the experiment cold.
Yes. We have to keep the experiment at about 50 millikelvin, which is 50 thousandths of a degree above absolute zero.
Just a fraction of a degree above absolute zero? Translated into Fahrenheit, that's like 460 degrees below zero.
So in other words, it's cold enough so that the air we breathe freezes solid.
Absolutely.
So there's frost everywhere.
But now, there's another problem. The frozen detector is so hypersensitive, lots of things could set it off. Like cosmic rays, particles that shower Earth from space. So this is why the whole lab is deep underground.
So the bedrock,
the half a mile of rock
above
is a shield.
Is a shield. So the cosmic rays, these are high energy particles from space.
From space.
Okay. So you're protecting yourself from space.
And it's not just cosmic rays. Even underground, there are other tiny particles flitting around us, including photons and neutrons that can fly out of the surrounding rock. So the detectors are cloaked in layer upon layer of shielding, all in an effort to filter out everything but the dark matter. And how are things going so far?
Okay. How many dark matter particles have you found so far?
None.
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 It's not too surprising. The quest for dark matter here on Earth has only just begun, and bigger and more sensitive detectors are already in the works. Still, you might wonder, could it be that dark matter is something that's just out there in space and not down here with us? Astrophysicist Richard Massey says, not likely. He's got the first ever 3D dark matter maps to back him up. But how do you map the unseeable?
So we can't see dark matter directly. It's completely invisible. But we can work out where it is by its effects on the ordinary matter that we can see.
In other words, you can see dark matter's gravity. That's because, according to Einstein and nearly a century of experiments, what gravity does in the universe is bend space. Massive objects like the sun actually bend and stretch the contours of space. That's what keeps smaller objects like Earth in orbit. And if space is bent, so is any light that passes through it.
So let's debunk the whole idea that light travels in straight lines. Light travels in what it thinks are straight lines. And because space is warped and bent, even the straight lines that light rays travel along are actually bent themselves.
The phenomenon is called gravitational lensing. Think of what a thick magnifying glass can do to the text of a book.
When we put a magnifying glass in front of it, we start seeing a distorted image. And gravitational lensing to find dark matter works in a very similar way.
A huge clump of dark matter and the enormous gravity it creates would bend areas of space so much it would act like a giant cosmic lens, distorting our view of distant galaxies. The more distortion, the more gravity, and, Massey assumes, the more dark matter lies between them and us.
So the final result is that we end up having this map of where the dark matter is in the universe.
Maps such as these are now revealing that galaxies like ours are completely enveloped by giant clouds of dark matter.
Wherever there's ordinary matter, so even here, there is some dark matter. It's everywhere. The two really have gone together hand in hand.
In fact, As the universe evolved after the Big Bang, dark matter may have served as a kind of cosmological glue that over time helped pull stars together to form galaxies.
We owe everything to dark matter in two ways. Firstly, it holds the whole universe together, but then it also, crucially, inside that, it forms this scaffolding in which the ordinary matter can later grow.
We are so lucky to have dark matter because we wouldn't even be here otherwise. It was the gravitational attraction from dark matter that pulled together this diffuse gas that eventually formed our Milky Way galaxy that we live in. And if there were no dark matter, then our galaxy would in fact never have formed.
If that's true, then it's not just our Milky Way. Across the universe, none of the billions of galaxies out there would have formed without the gravity of this mysterious stuff. Now, we just need to find out what it is.
It's really astonishing that there's 5 times more stuff out there than we know of, and that we've been at this as a community for over 70 years, and yet it might be now in the next few years that we'll figure it all out. It's just incredible.
That voice in the wilderness.
For most of us, a stroll down memory lane is an easy trip. There's a good one. But for the tens of millions suffering from memory loss, like those with Alzheimer's disease, it's different. In some cases, memory might still be there, but the pathways in our brain that give us access to those memories might be broken or blocked, leaving the memories out of reach. But what if your brain could build new pathways to lost memories? As correspondent Peter Standring reports, some new research shows that someday that might just be possible.
People always said that she was the life of the party. She was very energetic. She was well known in her circle as a dancer. She was just a bubbly, exuberant young woman. Do you remember who these folks are?
Oh, yeah.
Tilly Wiener is 84.
Not exactly, no.
Those are your great-grandchildren.
Really?
Really?
Until a few years ago, Tilly was living a comfortable life, retired in Florida. But then she started having trouble with her memory.
She had a car accident. Then she got a ticket for going while the school bus was stopped. Then there was another car accident, and I started thinking, I don't know if she's safe down there.
Doctors said Tilly probably had Alzheimer's. She moved to an assisted living facility, but her memory just got worse and worse.
One day, they called and said, your mother's standing in her room with her pants in her hands, not knowing what to do with them. And then she started staying in bed all day and staying in her room more. Finally, one day, the phone call came. They found her in the stairwell, crying, sitting there saying, where am I? Where am I going?
Alzheimer's was robbing Tilly of not only her memories, but also her personality. Her family moved her out of assisted living to a new nursing home, and suddenly they noticed a surprising change.
Hey, good job, Tilly.
But this very loving, bubbly, almost girlishness has emerged since she's been here. She became involved again. she sort of sparked a little bit more. Her exuberance came back.
Woo, Tilly!
Somehow, putting Tilly in a new place brought back parts of her personality that seemed like they were gone forever. How is that possible?
Good job, Tilly. All right, ladies and gentlemen, Tilly!
When patients like Tilly regain function or seem to get their memories back, even for a short period of time, it provides clues to an amazing idea. Maybe memories aren't totally lost. Maybe they can be restored. At MIT, these mice may help us find memories that are buried in our brains.
So, Dr. Tsai, what room is this that we're in now?
So this is a room where we test the behaviors of mice.
And what have we got here? I'm sure this is not a hot tub.
This tub of water is a way to test learning and memory.
You can see we fill up the tank about halfway with murky water. So when you place a mouse in the tank, it cannot see through. And then we place a platform that's submerged underneath the surface of the water.
Now, don't worry, the mice know how to swim, so what they have to do is learn where the platform is and climb onto it. They practice for just 90 seconds at a time, a few times a day, and pretty soon they figure it out. And once they get the hang of it, they always remember where they can find the safe haven. But after they've learned the route, Tsai gives them a toxic protein that destroys brain cells. And when she puts them back in the water, the mice forget where the platform is and have to be rescued.
So this mouse's brain is basically not functioning properly?
No. If the mouse, after vigorous training, still cannot find a platform, it clearly is impaired in their learning ability and cognitive function.
Tsai wanted to find out, could those lost memories be restored? So, after they're nice and dry, the mice get a treat.
What is this, Dr. Tsai? I'm assuming that it's not necessarily a playground for the mice.
Well, this is a Disney World for the mice.
This experiment tests something that has been studied for many years but never really understood. It's called environmental enrichment.
Now, if you keep rodents in very enriched environment with lots of toys, house them in groups with lots of companions, then these mice somehow they become smarter.
After just a short vacation at Disney World, Tsai puts the mice back in the water. And here's the surprise. Amazingly, they swim straight to the platform.
So after a few weeks in Disney World, they go back into the water maze and they're able to find the platform.
Right. They can find the platform much faster.
Somehow, the mice got their memories back. But what's actually happening inside their brain cells? There's a possible clue in the work of neuroscientist David Sweat. His hobby is painting abstract images of the brain cells he studies in his lab.
The work that's going on in the laboratory and in neuroscience in general right now is the most interesting thing in the world, so that's what I need to paint.
Sweat lost his mother to Alzheimer's, and now he's trying to figure out new ways of understanding how brain cells create memories. His search starts deep inside neurons, where long strands of DNA are tightly coiled around a group of proteins called histones.
It's as if you were winding sewing thread on a spool. The histones are kind of like the spool, and the DNA is wrapped around the histones like a few wraps of thread around a spool.
Analyzing brain cells from normal mice, Sweat discovered that when DNA is wrapped tightly around the histones, genes are hidden. But when the DNA loosens up, genes involved in learning and memory are exposed and can be switched on. And as that happens, the brain cells appear to be making more and stronger connections with each other. This was a new pathway into the creation of memories that had never been understood before.
When you have a new process like that, you can think of entirely new and different ways to go about attacking the problem of memory dysfunction.
Back at MIT, Li Wei Tsai had also discovered something new. The mice's stay in Disney World seemed to have sparked the same process, even in their impaired brains. Their DNA was also loosening up and making memory genes more active. And somehow, even though they'd lost a significant number of neurons, this was helping their cells make new connections, essentially rewiring the remaining neurons so their brains could work better.
And we found that even though these mice have fewer neurons, each neuron seems to be more effective.
What are the processes that are happening to allow this sort of rewiring?
That's a very important question, because if we understand that, then you can imagine that one day maybe it's possible to have a pill that we all can take, and that will have this magical effect.
A pill that could bring back memories? Well, it may not be so far-fetched. Sweat's lab has already studied a group of experimental drugs called HDAC inhibitors, the H stands for histones, that are involved in loosening up DNA in brain cells. And when the drugs are given to normal mice, they learn and remember better. So Tsai decided to see if they would have any effect on her mice with damaged brain cells. She took a new group of forgetful mice and gave them the experimental drugs. And within a short time, they also remembered how to swim straight to the platform.
We found that the HDAC inhibitors drastically improved the learning ability of our mouse model.
And when you realized that, what did you think?
I was overjoyed.
What's so interesting about what Li Wei Tsai has shown is that memories can be stored, apparently lost, and then regained. By taking that mouse and either giving it an enriched environment or certain drugs, she can show that those mice can recover some of those memories.
There is no way to know whether these new discoveries will ever apply to humans or lead to treatments for memory disorders. But for now, they're a tantalizing insight and a new direction for more research into the mysteries of memory.
This is such a profound problem and is of such enormous significance because it affects the most fundamental aspects of our character, personality, of who we are, that any advance is a step forward.
I think these experiments are just plain amazing. They tell us what the potential is, that there's so much more potential in situations where we might have given up all hope.
There aren't any drugs to reverse the effects of Alzheimer's in humans, but Tsai's experiments may help explain something families have known for a long time. The more stimulating the environment, the better patients like Tilly usually do.
Gonna feed the birds, okay? One, two, three, go!
Birdie, birdie.
Her new nursing home is centered on a philosophy of care called the Eden Alternative, with a special program to give Alzheimer's patients as much stimulation as they can manage.
Let's have a wonderful lunch together.
Everything that we try to do is resident or person-centered, to empower those people with dementia, to make decisions to the extent that they can.
What are you going to have?
I'll have the meatloaf.
And to provide a loving home for them, which is what they deserve.
After we bake the cookies, what do, Tilly? We put the music on and we what? We dance.
Tilly is thriving in this enriched environment.
You put your home.
She's made this place her own and made her life here her own.
You do the hokey pokey and
she just became happy again.
That's what it's all about.
They say a picture is worth 1,000 words. But what if those words are just lies? With digital technology, anybody can appear to be or do just about anything. So what do we do when seeing is no longer believing? When it's gotten harder to tell fact from forgery? Well, in this episode's profile, you'll meet a scientist who's developing the forensic tools to recognize a fake when he sees it. Hany Farid is 42 years old and spends much of his time making fakes and forgeries. Images that are meant to trick the human eye.
When I am creating a forgery, it is a little bit like being an artist. You have to think about, well, the colors and the palettes and the lighting and the contrast and all the various things that artists probably think about. I find it really fascinating to try to create these visual fakes. I think it's interesting purely from an aesthetic and artistic point of view.
But Hany is not a forger or a crook. He's a Dartmouth College computer science professor who likes taking chances. He rides a Harley.
There's something really exciting and risky and slightly dangerous about it. I wouldn't give it up for anything.
And Hany is anything but predictable.
So on any given morning, I might take a shower, brush my teeth, shave, get dressed, and leave. And on another day, I'll shave, shower, brush my teeth. Or I'll brush my teeth, shower, and shave. Or I'll brush my teeth, have my coffee, and then go back and do it. What happens is when I fall into a routine, I think my thinking falls into a routine.
Thinking is his obsession.
You have to wake up and you have to go to sleep thinking about the problem and turning it around and spinning it. So everywhere I go, I have a pad of paper and a pen.
What he's thinking about is something called digital forensics, an entirely new field that Hany helped pioneer.
The basic idea is, think forensics the way you would think CSI forensics, but now it's pixels instead of hair.
As a digital detective, Hany takes what he learns from making forgeries.
So imagine you're somebody who's trying to catch a counterfeiter. How do you learn? How do you learn how to detect that? Well, you have to know how they do it.
And he creates powerful software. When he runs that software on a photograph, he can show if it's real or fake, like this Time magazine cover of O.J. Simpson, well known to have been manipulated.
I think we do want to believe what we see. It's our first reaction. I, however, think that is changing. More and more, when people see photographs that are fantastic, there is an initial, oh, how do we know it hasn't been Photoshopped? The reality is that photographs have been manipulated since the 1800s, since the start of photography, actually. So you're talking about something that's been going on for hundreds of years. And if you look throughout history, in fact, all the great dictators doctored photographs to change history. Stalin did it, Mussolini, Castro, Mao. They all manipulated photographs.
In the digital age, we're flooded with images, and the problem of the tampered photograph has only gotten worse.
A picture with a flash. This is like computer graphics, right?
Hany and his team of graduate students have joined forces with the FBI and other law enforcement agencies. But how can they beat the forgers?
That's exactly right. So is this point?
Most of what we think about is authentication.
If you save it, does Photoshop preserve that?
Can you show that something has been added to the image? Has it been removed from the image? Has this person been airbrushed? Is it somebody else's head on somebody else's body? So think about all the types of digital fakes you've seen. You know, the guy holding the really big cat, the really big Hogzilla, all those things. We ask the question, is this a legitimate photograph?
Okay, so what if you have two images?
They approach it like a detective would.
In a sense, images contain natural fingerprints. So we build tools that can detect these fingerprints.
One of the most common ways of manipulating a photograph is to remove something or somebody from a photograph. And the most common way to do that is to typically take one part of an image, copy it, and paste it into another part of the image to hide that person or that object. And when you do that, you've left behind a very specific statistical trace. You've left behind two regions that are virtually identical.
And that process is called cloning.
Probably the most famous example of cloning was the photograph that Reuters published that came out of Lebanon after an Israeli strike. It showed smoke billowing out of a building.
To Hany, something about the smoke looked unnatural. But how could he confirm his suspicions? Hany created software that detects identical pixel patterns.
So we've developed a very efficient algorithm that can detect whether two parts of an image are identical. We call this the anti-cloning tool. The software analyzes it, and what comes back is a color-coded image that says all of these pixels, which we color-code in red, for example, are same as all of these pixels, which we color-code in blue. So there are these two highlighted areas. It's very distinct, and it's very recognizable.
Hany's software confirmed that the photographer had digitally added more smoke after the photo was taken. Portions of the image had been cloned. Hany was able to develop his next technique thanks to the budding relationship of Brad Pitt and Angelina Jolie in 2005.
This is when they were still rumored to have a relationship, and everybody was dying to get that photograph of them together.
So was this infamous photo real or fake? Hany could see with his own eyes that something was very wrong. His clues were the light and the shadows.
Interestingly, by the way, most people don't notice it. They look at the image, two beautiful people, who cares, right, where the light was? It doesn't matter to us.
Just by looking, Hany could tell it was a fake.
The light was off by a good 120, 130 degrees. It was completely opposite directions. So for Brad Pitt, the light was on his left, and for Angelina Jolie, the light was on her right.
Which means there were two separate photographs made to look like one.
So that made us think, well, this would be a really cool digital forensics tool. What if we could estimate from an image where the light was?
Thanks to Brangelina, Hany used linear algebra and physics to develop his light direction software. It can tell you where the light came from when the picture was taken. It was the perfect tool for the 2004 presidential campaign.
One of the most damaging political forgeries was the image of John Kerry sharing a stage with Jane Fonda at an anti-war rally. So this is when Senator Kerry was still trying to get the Democratic nomination for president. And when this image broke, it made the headlines. People were talking about it for weeks. What was interesting about that particular image is that when you look at it, you can't tell that the lighting is different.
The photo looked real, but when Hany used his light direction tool, it revealed a completely different story.
It was absolutely a fake. We were able to detect differences in lighting between John Kerry and Jane Fonda by as much as 30 degrees difference.
Which means, once again, this image was a combination of two photos. Hany's light direction software could determine lighting in 2 dimensions. But he wanted to find a way to work 3-dimensionally. The key was in the eyes.
The eyes are a wonderful thing because they are a partial mirror into the world in which you were photographed.
And we had this idea that you could actually measure properties of the lighting environment from reflections in somebody's eye.
If you look closely at my eyes, what you can probably see is that there must be a light off to my right and slightly above, and it's actually rectangular in shape. And you can see that because of where the white is in my eyes. And you can probably see a reflection of that directly in my eye.
Using the geometry of the human eyeball, Hany developed a tool that exposed the position of the subject and the light source in 3D. Armed with his new eyeball software, he was faced with this photo of the American Idol hosts.
The Associated Press was about to run this, and there was something about the photograph that bothered all of us when we saw it.
Once again, Hany's new software confirmed his suspicions.
When we went in and looked at the eyes, we could tell that the light in which each was photographed was completely different. The people who were photographed with 2 lights, we saw 2 dots on their eyes. For the person with the flash, we saw a very small dot in the center of their eyes. And for the other person, we saw a different shape in a different location. And so it was radically different lighting in that cases. And it was clearly a composite of 3 photographs. I think from the point of view of the Associated Press, this is not an appropriate manipulation, and they just didn't publish the photograph.
In this digital age, Hany's new technologies are indispensable. But developing a new field of science is never an easy mission.
When I first got to Dartmouth, my postdoc advisor said to me, I don't think it'll work. And when somebody who's a lot smarter than you says something's not going to work, you better pay attention. If somebody tells me something won't work, I'm more determined than ever to make it work.
Hany's strong will started a long time ago when he was a young boy growing up in Rochester, New York.
I think my grades and my abilities in school were either very good or very, very bad, and there was really nothing in between. There are things that really resonate with me, and I will commit myself to it, and there are other things that I find uninteresting, and I can't for the life of me make it work. And I just couldn't really get myself to do the work. I was like in the slow lane a little bit. My mother called me one day when I was in college. I was, I think, a junior at the time. I still didn't have a major. I was a C student. She read an article in the Time magazine saying computer science is going to be big. She said, you know, you should think about taking a class. And I thought, yeah, right, Mom. Like, what else would I say? But you know what? It sat with me, and I ended up taking a class, and it was great. It was one of the first things that I was actually good at, and it changed my entire life. Listen to your mother.
In less than a decade, Hany has taken his rule-breaking brand of computer science and mathematics and helped pioneer the field of digital forensics. And he's caught the attention of major players along the way. Now Adobe, developer of the software Photoshop, has invited Hany to work with them.
They were interested in collaborating with my lab at Dartmouth, thinking about whether we can transfer that technology into software that could actually be used by law enforcement, media outlets, scientific publishers, to bring some of the techniques that we developed to a broader audience.
Because of Adobe, the use of Hany software is likely to become widespread in the battle against the forgers. Soon, we may all know if what we're looking at is real or fake.
The research that Hany is doing is going to enable people to continue believing what they see.
So in the end, can Hany win against the forgers?
I think the game of forensics is not you stop forgeries. That's an unrealistic and naive goal. What it is you make it increasingly more difficult. I think at the end of the day, the average forger, the 14-year-old in Ohio in his bedroom making forgeries and posting them on the web, they will lose. We will win that game. There is no doubt about it. But if I wanted to play the other side, I will always be able to beat the authentication game. I'll be able to create fakes, but you won't.
In an election year, people might disagree about who makes the best candidate, but you don't hear much argument on the merits of democracy, that millions of average people can together make a wise decision. It wasn't always so. In the early 20th century, this controversial Englishman, Sir Francis Galton, tried to statistically test whether mobs of common folk were capable of choosing well. And, as our musical correspondent Rob Morseberger tells us, what Sir Francis actually found was that, mathematically at least, there's often wisdom in a crowd.
Sir Francis Galton was a nobleman and scorned the common masses. He thought that votes of governance should be left to higher classes. he'd prove with all the data from a contest inescapable of guessing even simple things the commoners were incapable.
Ladies and gentlemen, step right up.
What kind of contest might it be?
Guess the ox's weight and see. Guess the weight correctly and win a prize.
It's 100.
Said a little one.
That's much too light. At least a ton.
An eager crowd queued up to play. 800 made a guess that day.
So we had 800 data points.
And now the ox's weight is exactly 1,198 pounds. There are no winners.
Sir Francis knew the rabble would never guess the weight. How might they judge important things if left to meet that fate? With mathematics, he would show how far they went astray. But in the end, his theory was in total disarray. Because a curve of all the guesses...
Oh, that curve? It's the cumulative distribution function of the normal distribution. Sorry, that's what it's called.
Because graphing all the guesses and determining their mean...
I think he was talking about the median.
And determining their median, he showed that if the crowd were one, its estimate is keen. He showed that if the crowd were one, its estimate is keen.
Keen, yes.
That's because while no individual guessed the actual weight, the average of all the guesses is exactly right.
The average will generally be better than a randomly selected individual guess.
The average of the masses assures us of success.
I think he was talking about the median.
And the larger the number of guesses we toss in,
The more likely we are to get the right answer about the oxen.
this premature prognostication, they cannot help but scoff.
Galton should have gathered more data before he went shooting his mouth off.
Sir Francis's hypothesis was rocked by ignoramuses. He lost the proof he had avowed. He found the wisdom of the crowd.
If you have a group of people and they each have tiny bits of information, then you can learn a lot if we could just gather all of those bits together.
It's just like Wikipedia.
Well, this isn't exactly like Wikipedia, no. It's a little bit different.
It could maybe be Wikipedia. You don't even need to be an expert, but if you know something, then you're able to contribute, and that entry is able to be that much more informed.
Another sample of this fair?
Who wants to be a millionaire?
Yeah, the audience lifeline.
If a person feels like they can't answer the question by themselves, ask the audience.
The audience is right over 90% of the time.
There you go.
How about that, Gelman?
The wrong Gelman.
Sorry.
One by one, we're not too smart, but every guess, it plays its part. And when you add them up, you'll find the wisdom of the crowd.
And now for some final thoughts from the dark side. Consider all we've learned about the size, age, and contents of the universe. From its fiery birth in the Big Bang, through 14 billion years of cosmic expansion that followed. Even better, consider the powerful laws of physics that we've discovered that account for it all. Kind of makes you stand with pride for being human. But before you stand too tall, consider that at this moment, we can account for only about 15% of all the gravity we've ever measured in the universe. We're simply clueless about what's causing the rest. Not only that, If you add up all the matter and energy in the universe, it comes to just 4% of all that drives cosmic expansion. So we're clueless about that one too, with no idea about what occupies the remaining 96%. We call these two entities dark matter and dark energy. What are they? Maybe they're exotic, never-before-seen forms of matter and energy. Or maybe they reveal a hidden flaw in our understanding of how the universe works. But really, the two terms are just placeholders for our abject ignorance. We could just as easily have labeled them Bert and Ernie, or without a clue A and without a clue B. So we're left in a curious situation. What we know of the universe, we know well. Yet a larger cosmic truth lies undiscovered before us. A humbling, yet thrilling prospect for the scientist, driven not only by the search for answers, but by the love of the questions themselves. And that is the cosmic perspective.
Educators and other educational institutions can order this NOVA program for $24.95 plus shipping and handling by calling WGBH Boston Video at 1-800-255-9424. NOVA is a production of WGBH Boston.